Welcome back to 10 of Code. So today we're going to explore using Golang to create a connection to the Ethereum blockchain. If you're not familiar with Go or Golang, it's a relatively young programming language that is increasingly becoming more and more popular. It is open source and supported by Google. It's actually created by Google and then later made open source. It's well known for its built-in concurrency and robust standard libraries. There's also an Ethereum client that is implemented using Go. It goes by the name of Geth. You can check out a little bit more about it. I'll put the links down in the description. However, today what we're going to do is use Go to make a connection to an Ethereum client. What we're going to do is use Infura, which is a service provided to us by Consensus that allows us to connect to the Ethereum node. We can also connect to testnets as well. So without further ado, let's jump straight into code. Alright, so the first thing we want to go ahead and do is install Go for our respective operating system. I'm going to install it for my Mac OS here. Once you have the installer downloaded, we can go ahead and install the Go binaries. Alright, so now that we have Go installed, what we can do is check the version that we have. Let's clear my screen. Go version will return. We have Go 1.18. Head over to my documents and I'm going to make a new directory. Name it Go Ethereum. And then, it already exists. Looks like I already did it. So I'm going to CD into that. And what we're going to do on the side is open up an instance of Visual Studio Code. If you don't have it installed, please go ahead and do so. It is going to make life much easier for you. So let's open up a project. Alright, so I was able to open up Go Ethereum folder I just created within Visual Studio Code. So the next thing I'm going to do is create a main.go file. This is going to be the entry point to our Go application that is going to connect to the Ethereum node. And before we continue, I want to make sure we have the Go extension installed. I'm going to grab the one developed by the Go team at Google, and we should be able to get all of the benefits such as autocomplete. So the first thing we want to do is define that this is the main package. Second thing we want to do is import a bunch of libraries that we are going to use. And we do this by putting them in quotations. We'll need context. We'll also need FMT to output. And we're also going to get the log. Then we want to go ahead and import the Go Ethereum client from GitHub, and that's at github.com/ethereum/go-ethereum. And the next thing we want to go ahead and import is the Go Ethereum client from GitHub, and with Go you just specify the GitHub path. It's going to be github.com/ethereum/go and then Ethereum. And let's go grab the common package. And then let's do the same thing, but let's get the ETH client. And I think that is one word. Yes, it is one word. Okay. Perfect. So next order of business is defining the main function that's going to act as the entry point to our program. And before I continue coding, let's go ahead and trigger the Go Mod Init so we can initialize our project. So that is Go Mod Init followed by the project name. I'm just going to do Go Ethereum. And we will now get a go.mod file right here. And that will get rid of the error on line 1. One last thing we want to make sure we do before we continue writing the main function is getting or installing these packages. Just like JavaScript, when we do npm install, we have to do go get. And just like how npm install installs all of your dependencies, we have to do go get all of these dependencies, and that's why you are seeing the red underline here. So let's go ahead and fix the issue, and it's going to tell us right here the command to use. So let's go ahead and copy that, or you can just type it up. So go get and then followed by what we're going to get, and we don't need the quotes. And make sure you're doing this within the same directory of your project, so wherever this go.mod file is created. You'll see that's going to go ahead and download our dependencies, and we're going to do the same with the second one. All right, so once we go ahead and refresh our project, you'll see the errors are all gone and we can continue writing our functions. So the first order of business within the main function is to connect to the Ethereum node. What we want to do here is say eth_client.dial, and we're going to pass it an endpoint that leads to an Ethereum node. And like I mentioned earlier, we are going to use the Infura node. So let's go ahead and navigate to Infura. And if you haven't logged in already, please do so and create a new project. Once you create a project and you're at this view, you can click on project settings at the top right hand corner and you can grab the endpoints. We're just going to use mainnet for this example, and let's copy the first endpoint that's available to us and paste it right in the dial function. And don't mind these underlines, it's just going to complain saying we haven't used it yet, so we will use it momentarily. Now what we want to do is store the return value of this dial function. It has two possible values. One is the connection itself, and the second one is any errors that it may encounter. With Go, error handling is slightly different than traditional languages. What we do is check if this error variable has anything in it, because if it does, that means we encountered an error. So what we can do here is say if error does not equal nil, do this. And what we're going to do is just log failed to connect to ETH node. And looks like we have an issue here. Oh, and then I have to add this here like that. Perfect. And then we can also optionally pass in the actual error itself to the log statement, so we see what actually happened. All right, great. So we've handled the case that we encounter an error when connecting to the Infura node. All right, so in order to use concurrency within Go, let's first create a context, and let's set this equal to context.background. And I'll show you in a moment how we're going to use this context. So now we have this context created. Let's attempt to get a transaction from the Ethereum node. So in order to do so, all we have to do is say connection.transaction by hash. And the first parameter we want to pass is the context. The second parameter we want to pass is the actual transaction hash we want to look up. We do have to convert the transaction hash from hex to a hash, and we can do that using the common library we just imported from the Go Ethereum package. And we say common.hex to hash, and we pass in the transaction hash that we want to search for. I'll just pull up Etherscan really quick and get a random transaction. So this is the latest transaction I'm going to look for using the Infura node. All right, so now that we're here, we have a couple of things that is returned. So we have the transaction itself, and we also have this pending flag. This pending flag is a Boolean, and if it is true, that means the transaction is pending, and if it's false, that means it's not pending. So we can check if pending, then we can say fmt.println, and we can say transaction is pending. Else, let's just say fmt.println and follow that by transaction is not pending, and then follow it by the actual transaction. I guess we can do the same thing here, follow it by the transaction. Perfect. So we have this connection that is created using the Infura node. We check if that connection successfully connected. If it didn't, we log a fatal error. Then we create a context which allows us to create communication between the concurrent ETH node communication and our main application. Then we use a combination of the connection that we created earlier and the Go Ethereum client to query the blockchain for a transaction by a specific hash. Then depending on the answer and depending on if the transaction is pending or not, we print out these following statements. So let's go ahead and give it a try and see if this will run. Give it a shot. All right, so it looks like we received a transaction that is not pending, and this is the object of the actual transaction from on-chain. And that was all done using the code that we wrote. So as you can see, it's a very straightforward approach. We just used Infura, which allowed us to create a connection to an Ethereum node, and then we used Golang to actually create that connection and make use of it in the way that we did. In the following videos, we will learn how to make a more complex application using this connection to the Ethereum node. Thank you much for tuning in. Again, if this video was helpful or you learned something new today, make sure you give it a like, comment any thoughts that you may have, and make sure you subscribe and click on that notification bell so you are notified every time I drop a new video. I will see you in the next one.